All right, so the first one I assigned was F1, and it says to graph inequalities. This one just says x is less than 1. So 1 is where you're going to go and click. Now, because it doesn't have an equal sign on it, it's going to be open. So I guess we just click again. There we go. And where are the x's that are less than 1? They are this way. You do have to go all the way to the end to get the full one. Oh, and I guess we click on it. What did I do? It's open and it goes this way. Why does it make it dashed? Those are all the numbers less than 1. All right, this one we go to -6. It's got an equal sign, so it's going to be closed. And where are the x's that are less than or equal to -6? They are, you just keep going until you hit the arrowhead and you click. It really doesn't seem to have anything too difficult. -45, close circle, and less than. Maybe I should look for something that's greater than. Do they have any greater thans? Why did it come out as less than? This is so sad. Anyways, if it's greater than, it's going to go the other way. All right, the next one is F2, writing inequalities from the graphs. And some of you guys need the skill. No, I thought it was the 2 variable one. This is the 1 variable one. So this is going to be the x's that are less than or equal to, because there's a closed circle, 1. Once again, it's going to be the x's, closed circle, so it's less than or equal to, in this case, -2. We need to give such easy work. You see, all of them are going in the same direction. What is this? Where's the variability? Y'all see this, right? Did they all go in the same direction for you guys? Be x less than or equal to 200. I don't know. It's a conspiracy. F2. I think I also gave, no wait, what did I do next? The piece? Nobody's going to check for me? That's fine. All right, I'll just finish the F's. Solve 2-step linear inequalities. Oh, then you come to decimals and you do 2j minus 2 less than 4. But you see, you get a little triangle. Decimals is like, no, I don't like j. So you're just going to have to erase the j and put an x. You see that? So now, what x value is this? That x value is 3. All right, and you see how it's shaded in all the x's that are less than 3? So this is going to be x is less than 3, and it's a dashed line. Let me emphasize this in the video. It's a dashed line, so that's why there is no equal sign on my inequality. What? I put x instead of j. Okay, yes, we have to go back to the original variable. Okay, this is now personal. Here we go, 2w, wait, minus 2 greater than or equal to 8. Oh, it doesn't like w, so we're going to have to do x. All right, it's a solid line, and it's all the numbers that are bigger than 5. So w is greater than or equal to this one. You got to click on the little box, I guess. 5. Crossing our fingers? Yes. Again, because I need to reestablish number 1 on this server. -1 x minus 6 greater than or equal to -2. Okay. And of course, if you can't find it, you just search for it, or you zoom in or zoom out. All right, so it's all the numbers that are less than or equal to, because it's solid, the -4. But it's not x, it's p. You will not get me twice. P. Much better. Less than or equal to, what do you say? -4. So what do you guys think? Piece of cake? Yes. Okay. Mm, graph solutions to two-step linear inequalities. Got it. Solve the inequality and graph it. Okay. 2 plus 2x less than 10. Remember, decimals is not going to like the y, so we got to call it x in decimals. And it looks like it's all the numbers that are less than 4. Dash line, so there's no equal sign. So you can write that somewhere if you want to. X is going to be less than 4. And so you go to +4, open circle, and you just slide this way, click on the arrow. Ah, excellent. All right, again, it says J, but Desmos doesn't like J. It only likes X greater than 9. And that's a 4. So it's going to be all the numbers greater than 4. Right? Dash line, so it's just regular greater than. Oh, I go to 4, open circle this way. Right? All the numbers greater than 4, so dash line, so I do an open circle. This is too much fun. -2 plus 4x less than or equal to 6. So the dashed line, so it's going to be a closed circle. It's all the numbers less than 2. Circle. Boom. Yeah, I'm too good at this. Next, it was the piece, correct? All the piece. Does xy satisfy this inequality? Let's find out. Y less than 2x plus 8, and then parentheses 8 comma 4. Are we paying attention? So where does the dot lie? See how it lies in the shaded area? Yes, it is a solution. Okay. Next, I'm going to plot the new one, which is 4x plus 11y greater than or equal to 15. And the point that I'm checking is 1, 1. So I'm going to go ahead and make these changes. All right, those of you testing, keep on testing. All right, so it lies right on the line, and the line is solid. So is it a solution? Yes. The points on shaded places and solid lines are solutions. Y greater than or equal to 3x plus 6. And the point that we're checking is 7 comma 1. I don't see it anywhere. Oh, there's my point. So you see how my point is in the non-shaded area? So that means it is not a solution. Okay, but you have to follow the rules that I gave you in class, and I said solutions are points that are in the shaded area in solid lines. Non-solution are points that are on the non-shaded area, and or if your line is dashed and they're on the dashed line. Okay. Linear inequalities, solve for y. All right. Sometimes it helps to do it this way. If not, you might get stuck actually having to do it by hand, but then well. So probably do the slope on this one, right? I found 2 points on that line. Why does it do that? Make them go away. Ha ha ha, I win, see? I'll just use a different calculator so that you don't go away. All right, so it's going to be -1 subtract 0 over 0 subtract -0.2. -5. So my slope is -5. So it's going to be -5. Oops, my bad, over here. -5x. And what's my y-intercept? Y'all see 0 comma -1. So -1 is my y-intercept. -1. All right, so that's the mx plus b part, correct? Now y. Where am I shaded? Above the line or below the line? Above. Okay, that's why it's greater than. And then, is it a dashed line or a solid line? Dash. So that's why I'm going to leave it as a regular greater than symbol. No equal sign needed. Cross our fingers. Yes. All right, let's do it again. I'm in the middle of this, so the rest of you, please keep checking in Google Classroom and take all your assessments. As soon as I'm done with this video, I'm going to end the assessments. Y'all can test for the entire period, okay? Okay. Okay. Then it's expired. I can't do anything about it. Okay? Not right now because I'm doing the video. 16x plus y greater than or equal to 17. Okay, so once again, I'm going to try to make this. So I'm going to use this point. Ooh, that's not going to work, you see? That's too decimally. But it looks like this one's going to work. You'll see 1 comma 1. Yes, Miss Medina, we see it. I'm going to use 1 comma 1. I'm just writing it because I don't have paper on me. And what's the other one? 0.17. All right, so those are the 2 points that I'm going to use for my slope. I'm going to use this calculator. I don't even think I have to use this calculator. I can continue on decimals now. It's going to be 17 subtract 1 over 0 subtract 1. It looks like the slope is -16. So it's going to be -16x. All right, and what was that y-intercept? 17. I have to remember to click on this window. Plus 17. All right, I'm going to go to the front. Y. Now looking at this diagram, is it shaded above the line or below? So above is the greater than. Now, does it have an equal sign? It will have an equal sign because it is solid, correct? It looks like I have to choose from these. There we go. So my y values are going to be greater than or equal to this line. So all of these numbers above this line or on the line. All right, should I do another one on this or just move on? If not, just rewind the video and listen to my wonderful dialogue. What? Work, work, work. Graph this inequality. Oh, well, look, watch and learn from the pro, from the master. Y greater than or equal to 5. It's all red. Oh, but if you zoom out, look what happens. So it's a horizontal line that goes through 5. Now, is my line solid? Yes, my line is solid. Clear? And it says select the region to shade it. Ooh, got it? Impressive, Miss Medina. I am impressed. Thank you. Graph this one. So then you come here and you say x greater than -3. And so it's a vertical line that goes through -3, -1, -2, -3. And it's dashed. So you see those three little lines, three little dashes on the line. I click and it makes it a dash line. I click again and I get a solid line. Click again, I get a dash line. Now, where am I shading? I'm going to be shading on this side. Wait, did I get it right? I did, right? I forgot to check. I was looking somewhere else. So are we okay with this? I mean, this one, you see how this one is already in slope intercept form? So here we just have to go to 5. And the rise is 1/2. 1/2. It's a dashed line. So I'm going to put 3 dots there, dashed. It doesn't matter. You can still go here, really, honestly. I would love for you to be able to do it 100% without it, but here we go. So it says less than, so the shading is going to be below. So you should double check in Desmos to make sure you're plotting it correctly, okay? All right, so I hope that was enough on that. Which one was that one? 3? 4? What is this? Oh, yes, this is actually a question on the test. You have to be able to look at the graph and know what the linear inequality is. And so in this case, it's going to be y equals mx plus b, right? So that's going to be your basic structure. It's shaded below, so it's going to be less than, correct? And it's dashed, so it's just regular less than. The y-intercept seems to be at 1. At 1 right here. So this b is a positive 1. Now the slope. Okay. So I'm going to be using this point right here. Can you all see the little mouse? And then this point right here. So that's a rise of 1 and a run of 3. So 1/3. Now you see why I made you practice being able to read your slope? Is it gonna accept it like this, or do I have to use this one? All right, see, you didn't mark me wrong. It did not mark me wrong, y'all see? There's no fear. All right, this one, once again, is gonna be your basic structure, y equals mx plus b. You see how it's shaded above? Yes, Miss Medina, I do see it. So it's gonna be greater than. It's dashed, so it's regular greater than. My y-intercept is -1. Ms. Vanilla, you're making this sound too easy. When I'm at home, it's so difficult. And now we have to do slope, rise over run. Oh, this is perfect. The slope is really easy. Look, from here to there. So the slope is up 1/1, so just 1. And so we just got to get rid of the m. Good. Yay. And this is why you have to know how to plot lines, because in Unit 2, they're linear inequalities. It uses everything from plotting lines. All right, that was P4, almost done. P5, right to, I'm going to make a separate video on this one, okay? We haven't covered that in class yet. That's P6, that was P6, that was P5. All right, a solution. All right, so with this one, you go to Desmos. X is less than 3. Next line, x plus 4y greater than 10. Now, when you look at this diagram here, okay. Now, this circle right here, if I click it, you see how the red disappears? red comes back. If I click here, the blue disappears, right? So all of this shaded red is the solutions for the red one. Okay. All of this shaded blue is the solutions for the blue one. But where can I find the solutions that are both solutions for the red one and the blue one? This is lesson time. So the solutions that are good for both of them is right here where the colors overlap. These right here are only solutions for the red function. These are only solutions for the blue function. These are no solutions for nobody. And this is solutions for both of them. So when we have a system, the solutions are going to be found in this area. Now, if they're on this line, they're not solutions because it's dashed. And if they're on this line, they're not solutions because they're dashed. So now where is 9, comma 3? Right? Let me see, 9, 1, 2, 3 right here. So is 9, comma 3 a solution? In fact, if you don't plot it, 9, 9, comma 3. And you see how the dot appears? Instead of trying to figure it out by hand. And so does it fall in an area where we have solutions for both of them? No. So is it considered a solution? No. If they were asking if it was a solution for the blue one, then yes. But we want to know if it's a solution for both of them, for the system. And so since it doesn't lie where they overlap, it is not a solution. Right? Another one. It's actually kind of fun because it takes a lot of typing and makes it, it says 5x plus y. So I hope you're able to knock out a lot of these IXLs tonight, since I'm showing you how to do them quickly, okay? The test is going to be on Tuesday. And for the rest of the Friday and Monday, we're going to spend it on those word problems that I told you I was going to make a separate video. Those word problems and actually writing the system ourselves. That's the only way we're going to pass the test. Be able to read and write the system and then answer a whole bunch of questions on the system. All right, 5x plus y greater than or equal to 8. And then 3x plus 2y less than 10. And is the solution 1, comma 3? All right, ooh. All right, so it's already, let me see. Now, remember, this light blue is only answers for the blue one. The light red is only answers for the red one. This overlapping region is where we have answers. Now, this point lies on a solid line, yes or no? This solid line is one of the borders of where we find the solutions. That being the case, then yes, this one is also the solution. All of these points on this border right here are solutions. Now, if it had been on this dashed line, then it wouldn't have been a solution. All right, so let me ask you a few questions, okay? What about this point? I feel like 2, 2, comma 1. What about that point? Is that a solution? Which is right here, 2, comma 1. Yes, it is a solution, okay? What about if I plot -1, comma 3? Is this one a solution? Pay attention, I'm trying to teach everybody. Is that one a solution? I'm trying to make a really good point. This one's not a solution. All right, how about 5, comma 7? Where did it go? Over here. Is that a solution? No. I'm about to make a really, really good point. What about 1, comma 3? Is 1, comma 3 a solution? Yes. What about 2, comma 2? 2 comma 2 is not. Now, what about if it was a point right here where these two lines intersect? One of them is solid and the other one is dashed. That means it is a solution for the one that is solid, but it's not a solution for the one that is dashed. So we have to say it's not a solution because it doesn't qualify for both of them. It has to be a solution that is a solution for both of them, not just one of them. So if your dot were to lie right here, where the dashed line and the red one overlap, it wouldn't be a solution because one of them is dashed. Okay. All right. So I hope I kind of made that point. It's important. And we said 1, 3. What was 1, 3? Oh, it was yes, right? Okay. All of them? Solve systems of linear equations graphing. Oh, well, I mean, you have Desmos, so you can start your y is greater than or equal to 3, right? And in the next line, what are you going to put? Y is less than 9. What are we doing? Graphing both of them? Okay, so with this one, you have to make sure you click on the one that you've got clicked. That's the one that you're graphing. Okay, so y greater than or equal to 3, that would be over here, my red one. So let me get rid of the blue one. Okay, y greater than or equal to 3 is going to be a solid line that is shaded. Never mind, this, we can only do the shading at the end, so it would be shaded above. Now I'm going to graph y is less than 9. I'm going to get rid of the red one and click on this one. So this is a dashed line across y equals 9. And so how do I get it to be dashed? You see the 3 dots? You click on that, now it's dashed. Now we have to shade. Select the region to shade it. Do we just shade the answer? All right, so now when you look at both of these, where is the region where they overlap? In between the lines, correct? So then that would be where the solutions are. The points on this solid line would be solutions. The points on the dashed line would not be solutions. And hopefully I'm not wrong. Let's do something more difficult. More difficult. Here we go. Y is greater than 1 over 3x minus 6. I made a mistake, right? Somewhere. Greater than? Okay. Well, I'm only going to be able to do one at a time, so I'm going to pick 1/3 minus 6. Okay. Well, actually, I can do it just from, it's in slope-intercept form. My y-intercept is -6, and my slope is 1 over 3. So 1 up and then 1, 2, 3 over. It's a solid line. There. I'm going to do this one, the other one. I got to come down here and change. And it goes through -2. And the slope is -8. So that means I got to drop 8 and run 1. 1, 2, 3, 4, 5, 6, 7, 8. And run 1. And this one is a dashed line. So here we go. Now, when I look at both of them, where is the region where they both overlap? Amy, we have a gift for you. Say thank you since he walked all the way over here, okay? Thank you, Mr. Wilkerson. Yay. All right. So does everybody see that the overlap area is over here? So then I would shade. You got to click on shading. There you go. Too easy. Too easy. Who's giving you this easy homework? Can we get all of these done tonight? Yes? Excellent.